Okay, welcome to section 2.3. We're talking about statistics again, and this time it's all about analyzing graphs. Let's take a look at what we can find out. Okay, number one, what your graph needs is a title. You need a label saying what's on each of the axes, the horizontal and the vertical axes. You need where the data came from, sometimes the data itself. A couple of definitions. Time series graph is one that shows values changing over time. Take note that the time values, days, years, whatever they are usually on the horizontal axis. So if you've got it on the vertical axis, maybe you've got a reason for that, but it's very unlikely that that's going to be a good way of showing it, because our eyes go or scan from left to right, and that's how you should have your data as far as the times. 2001, 2003, and so on should go from left to right. The other kind you might see is a cross-sectional graph, and that's information you got at one point in time as opposed to a sequence of times. Next, we've got a pictograph, and it's a bar graph. You know that those are graphs that don't have the sections touching, and it uses pictures instead of bars. Next, take a look at this graph, hit the pause, see if you can find out what the mistake is, any. What errors can you fix in the graph? Here's a graph. Here's the one actually that we want to analyze. So take a look at that. Can you find any errors in that? Pause it from every 10 seconds or so, 30 seconds if you like, whatever, and then come back. Okay, you ready to keep going? Have you found something? Well, notice that the x-axis does not have a consistent scale. Look back again. See the scale at the bottom? You have 1938, 39, 45. You jump 1 year, then you jump 6 years, then you jump 5 years and 6 years. It's really crazy. And some at the end go 1 year at a time. That is not the way to show a time, because that's not a consistent display of how the time rolls by. So you need to adjust the x-axis where the time is to have a consistent scale. Here's how it should look. Notice the dates at the bottom, the 35 to 2010. Now the dots aren't at a consistent distance, but that's not as important as the fact that the time is. So it gives you a proper idea of how the minimum wage rates have changed from 1935 up until near our time. Here are some ways of describing graphs. It's uniform if the frequency is almost the same from one category to another. It's symmetric if you could draw a vertical line in the middle and the left side and the right side look like they're mirror images. Then again, it could be skewed. Now this is important. There are two kinds of skewed, right skewed and left skewed. The key is this: where does it tail off? The part that tails off points in the direction of the skew. So if the tail is on the right, it's right skewed or skewed to the right. That means that most of the values are on the opposite side, on the left. Outliers are unusual values that don't seem to fit in with the rest. So here are some pictures. So the first one, notice this is negative skewness. That's the same thing as left skewed, and you can tell it's left skewed because the tail comes off to the left. And if you think of it in terms of a number line, that would be toward the negative. So it's called left skewed or negative skewed. Also keep in mind, on the opposite direction from the tail is where you have the most values. Most of the values are here on the right side when it's left skewed. And over here, the tail is on the right, so it's right skewed, or if you think of it in terms of the number line, the skewness is toward the positive end, and the most values are on the opposite side. Next, here's an example of a uniform graph where almost all the frequencies, which are represented by the vertical axis, almost all of them are the same. In this picture, someone obviously made one that had exactly the same frequency all the way across, but that gives you an idea. Even if it's close to that, we would call it a uniform graph. Symmetric graphs, that means if you bend it through the middle, the left side and the right side match up, and you might have to rearrange things. For example, this third one, if we rearrange this, twist it to the right or to the left so that we can make the left-hand side and the right-hand side mirror images of each other. Some more on the next one. Left and right are the same. This is different, but they all have left and right the same. And this might look to you like a three-dimensional one, but again, the right and the left sides are mirror images of each other. Another one with 5 points, and again, symmetric because you can fold it on its middle. 6 sides, you've got several different possibilities here, and 7 sides, and so on. You get the idea. Outliers, remember the outliers are unusual events, so you can see that all the rest of the points seem to follow this straight line going from left to right, and this one value is up here, and we might, number one, we might be concerned there might be an error, or number two, there might be a story around this outlier. 2 different possibilities you have to explore if this is the data you've collected. Again, on this one seems out of place. Was it an error? Did you make a mistake in collecting data? Did you make a mistake in recording it? Those are things you have to analyze when you're looking at graphs from your data. Third one, there's one that's way far away, both left to right and up down. And last of all, we've got a bar graph down here, and there's one bar that's way far away from the other ones. Notice, by the way, just a note, why did I call this a bar graph? I call it a bar graph because bars don't actually touch each other. If they touch each other, it's called a histogram. And next, if you're a runner or you do some running, you might recognize this. It's a sample of pulse rates for a sample of runners. I find this rather interesting because right in the middle it has about 80 beats per minute. Now, I was wondering where I would fit in, and as soon as I saw it, I realized I'm way over here. But yet, when I was a teenager, I would have fit right in the middle. That's before I started running. And now I'm down in the mid-50s, sometimes lower. Where are you? But the point on this is, what's the overall shape? To determine the overall shape, you might take each of these bars, notice it's a histogram this time, take the midpoint of each one, so see if I can get a point here. There we go. Pen. So you take the midpoint of the top of this one, midpoint here, midpoint here, and those represent the frequencies for each one. And then you connect those with straight line segments like this. And before you're finished, do one other thing. You always show one empty category to the right or to the left of your bar graph. So you would also have one down here and connect that. One down here, connect it with that, and there's your completed graph for a line. If we connect those and make it into a smooth curve, then we've got something like this, which you'll recognize is very similar to a bell curve. And it's symmetric. Left and right fold over on each other. And that's it. Hope you enjoyed this short tour of analyzing graphs. See you next time.